Hello. In this video, I'm doing applications of linear equations to different types of situations, to geometry, to investment problems, and to motion. So the first application is to the volume of a rectangular box. So for that, we need the volume of a rectangular solid. Let's say we have a solid with a given length, width, and height. So the length of the solid is L, the width is W, and the height is H. And by the way, this is on page 101. So the volume is length times width times height. So the problem states that the storage bin is in the shape of a rectangular box. Find the height of the box. If its length is 18 feet, its width is 8 feet, and the surface area is 496 square feet. So actually we need, well, this is the volume. And we are using the surface area. The surface area is going to be the sum of the areas of the 6 faces. From this perspective, front and back is length times height. So that's 2LH. And then the top and bottom. So the top and the bottom are both length times width. Add them together. The front and back are both LH. And the left and right are HW or WH. Okay, we know that the surface area is 496 square feet. So, and we know that L is 18 and width is 8. So this is 18 and this is 8 feet. And the surface area is 496 square feet. So let's plug it in. 2 times 18 times 8 plus 2 times 18 times H plus 2 times 8 times H is 496. And we are going to solve this equation for H. So 2 times 18 times 8 is 288. 2 times 18 is 36. And 2 times 8 is 16. Okay, we are getting closer. We are going to pass the 288 to the other side and combine 36H and 16H. So 496 minus 288 is 208. And finally, pass the 52 to the other side dividing. 208 over 52 is 4. And that's it. The height of the box is 4 feet. Yeah, so the height of the box is 4 feet. Okay, so that was an example to surface area. The next example is an application to motion. In motion problems, we use the formula, well, the idea that velocity is distance over time. Or V equals S over T, where the variable being that. V stands for velocity, S stands for distance, and T stands for time. Or we can have it in different ways. If we solve this equation for S, distance is velocity times time. And if we solve it for T, time is distance over velocity. On the same page for 101, we are going to do number 20. Actually, we're doing number 27. On the next page, number 27. Callie took 20 minutes to drive her boat upstream to water ski at her favorite spot. Coming back later in the day at the same boat speed took her 15 minutes. If the current in that part of the river is 5 kilometers per hour, what was her boat speed? So if she took the same path or the same route, it took her longer to get there than to return. That means when she was going against the current, and when she came back, she was going with the current. So we're going to make a chart with distance, velocity, and time elapsed. Yeah, so we need to make a table. And we have two trips. We have the going trip and the returning trip. The variables are rate, that is, rate is velocity, T, and D. So this is rate or velocity. T stands for time elapsed, and D stands for distance. So we're going to call. Usually from the question of the problem, you determine the variable. The question is, what was her boat speed? So this is going to be the variable. That's going to be the boat speed. So far we know that the boat speed, so if it took her longer to get there and shorter to come back, initially she was going against the current, so that was the boat speed minus the current of 5 kilometers per hour, and returning she was going with the current. Then it took her 20 minutes to get there and 15 minutes to return. And we need to find the distance. Now, there's one more thing. The rate is in kilometers per hour, but the distance, or not the distance, but the time is in minutes. So we need to have everything in hours. And we know that 20 minutes, it's 20 over 60. That is 20 minutes over 60 minutes, or one third of an hour. And 15 minutes is a quarter hour. So the distance is going to be the same. Going and returning is the same distance. So going is 1/3 times x minus 5. And returning is 1/4 x plus 5. Okay, so I will update this chart. Yeah, I will update the chart. We have the going trip and the returning trip. And then the variables were the rate or velocity, the time, and the distance. The velocity was against the current is x minus 5, with the current is x plus 5. The time is in hours is 1/3 going and 1/4 returning. And it's going to be the same distance each way. So going, the distance is 1/3 times x minus 5. And returning is 1/4 times x minus 5. X plus 5. So that's distance is velocity times time. So we are going to solve, since it is the same distance. Since it is the same distance each way, we are going to solve 1/3 times x minus 5 equals 1/4 times x plus 5 for x. And what we can do, we can start by cross multiplying. So cross multiply 4 and 3. So pass the 4 to the left and pass the 3 to the right. Then distribute. And finally, 4x minus 3x. So we're going to bring the 3x to the left and the 20 to the right with opposite sign. So 4x minus 3x is x, and 15 plus 20 is 35. And that's it. So her boat speed was 35 miles per hour, or kilometers per hour. And I will do one more application to investment. So I'm copying the problem. On page 103. A church building fund has invested some money in two ways. Part of the money at 3% and 4 times as much at 275%. Find the amount invested at each rate if the total annual income from interest is 2,800. So they are asking us to find the amount invested at each rate. We are going to find from the question of the problem, we can determine the variable. So we're going to let x. So one part was invested at 3% and 4 times as much as 275%. So x, that's going to be amount. This is going to be the amount invested at 3%. And 4x, 4 times as much, that's the amount invested at 275%. So remember the simple interest formula. Is I equals PRT. where P is the principal, R is the interest rate, and T is the number of years. Okay, let me write this down. You should have it in the previous video, but P is the amount invested. R is the interest rate. And T is the time in years. Okay, so the money invested at 3%. So the total interest X dollars were invested at 3%. So that's going to be 3% as a decimal. That's 0.03 times X times 1, but I'm not going to write times 1. That's 1 year plus 2.75% as a decimal is 0.0275 times 4X. Times 1, I'm not going to write times 1. That's after 1 year. And the total interest was 2,800. And we are going to solve for X. Okay, so 0.03. And then 0.0275 times 4 is 0.11 equals 2,800. 0.03 plus 0.11, that's 0.14 equals 2,800. And X is going to be 2,800 divided by 0.14. At the end, this is 20,000. And that's it. 28,000, a total of 28,000, not 28,000, 20,000 was invested at 3% and 4 times as much, 80,000 was invested at 75%. So these were the 3 examples, and thank you for listening.